coterminal angle. This key idea is angles coterminal to each other. The key things to remember about these two angles there that are coterminal to each other is that often they're not equal to each other, right? So I'm going to write one angle in here. That's my initial side. And here's my, let's say this is my terminal side. Angle going like this. That would be negative angle, correct? Can I say it 90 plus 30 is 120 degree roughly? Kind of roughly makes sense? You go 90 degree and 30 more degree. And then that's roughly there. That's one angle. And I'm going to change the color to make exact equal initial side. And so I'm just going to put it like this, but it's actually overlapped, right? And here's the terminal side. Also overlapped. There's another terminal side here. My rotation is going to be different. It's going to go like this. This is the positive or negative direction? It's positive counterclockwise. So what would be the angle? All of them together is 360, right? I used 120 there. So 360 minus 120, that would be 240. So if I put 240 there, these two angles have the same terminal side, the same initial side, right? But their angle measures are different. The black one, that one angle, if I call that one angle alpha and angle beta here, the measure of an angle alpha, m of alpha, is negative 120 degree, right? The measure of angle beta is positive 240, right? When we say two angles are equal to each other, everything should be equal. The measure is different, so it's a different angle. Angle alpha is not equal to angle beta. Okay? But what's the same about these two angles? Same terminal side, right? And initial side. Then what do we call this angle? But alpha and beta are, what's the adjective? Coterminal to each other. All right. The concept is easy. You know, some side there. But if I give you, I have an angle who has the same initial side. Same initial side. One is a negative 120 degree. The other is a positive 240 degree. Is this coterminal to each other? Backward question, right? Then you may sketch this angle carefully, somewhat figure it out, and that must be exactly coterminal, right? That procedure is something the next we want to do. If I have two angles, they have same initial side, and these two measures are given, how do you determine these two angles are coterminal to each other? One method, you actually sketch it. But if these angles are really ugly, then like 175, and it's not easy to sketch and not very precise conclusion, right? So here's the statement. Maybe we can call this one a little theorem. It's mathematical jargon. It's a statement which is absolutely true. If beta is coterminal to alpha, then beta and alpha, how do you think is related? Beta and alpha is equal or not? Is angle measure. I was wrong about this one here. Measure of that angle, beta, is not equal to measure of angle alpha, right? This statement is incorrect, correct? Then what should I do to the right-hand side so that these two are equal to each other? If they have the same initial side, if they're coterminal to each other, that means they have same initial side and same terminal side, right? If you look at the angle measure, they're not necessarily the same, like the before, right? But what would be the adjustment term? What should I add here so that they're equal to each other in terms of degree? Right. If you're terminal sided here, however you got it here, however you're crediting to do there, you must have, rotated full 360 degree forward backward to get here, right? So this is a 360, could be 360 times 2, 360 times 4, 3, or negative 4 in the backward direction. So we call this n, representing the whole number with a sign. It's called integers, so degree there. Where n is what kind of number? What's the jargon? Numbers representing plus minus 1 and plus minus 2, they are called integer, right? 0 is an integer, 5 is an integer, negative 5 is an integer, but 2.5 is not an integer. Okay? Does that make sense? You have on one angle, if you go backward and forward, one full rotation, 2 rotation, or backward and forward, you must be arrive in the other angle if they are coterminal to each other. Alright? So that's the statement. Was there a question or just stretching? Yes. A fair question. So we accept that larger magnitude here for physics application. Fair enough? Right. So n can be... Yeah.
It is logical then, according to that definition, for me to have a 720 degree angle.
Right. 720 degree angle usually means it's rotated 2 times. But its terminal side is usually what matters in geometry problems, so it's not a big deal. Great. All right. So let's see. Also, is something that follows easily is something corollary. So let me write it down. Corollary is also a mathematical jargon that if measure of an angle beta minus measure of an angle alpha, here I'm assuming at least their initial side is the same. There's no point of comparing these two angles if their initial side is different, right? So I'm assuming here the initial side is the same. If you've subtracted these two measures of an angle, if this turns out to be the integer multiple of 360, if that's so, then you can conclude what? What about alpha and beta? Alpha and beta are coterminal, right? So you're going to use this to EO to each other. All right. So suppose you have two angles whose measure is negative 120 and 240, and you want to know if they are coterminal to each other. Then negative 120 minus, what is the other one? 240, right? 240 degree, then what is it? Negative 360 degree, right? Where, I forgot to write here, where n is an integer. So, is this negative 360 integer multiple of 360? Yes, is the 360 times what number? Negative 1, right? Degree. So that must be integer. Plus 1 and minus 1 and plus 2 minus 2. Then you can conclude from the corollary that alpha and beta are coterminal to each other. Fair enough? Or if you want to create coterminal angle, you have one measure, you keep adding 360 and another 360, another 360, or subtracting and 360 and 360 and things like that. How about coterminal angle in radian? What could be different? If you want to change this theorem and corollary for radian version, what should change here? Instead of 360, what should I put? 2 pi. Pi is 180. 360 is 1 revolution. 1 complete revolution is going to be 2 pi. So instead of pi, you're going to have 2 pi in there. So rather than stating the same theorem and with this one thing different, I just overwrote here. If you replace that with the 2 pi and replace this degree with the radian measure, then this whole statement will change to radian version. Does that make sense? Yep. Yeah. So I think I have exercise problem ready for, maybe it's that. All right, here. Find angles that are coterminal to 30 degree, right? So why don't you go and find like 3 of them, right? See if you can use that formula. Again, I encourage you to not look at the formula I just went through, but try to remember the principle and see if you can pull that out on your own. So I realize that I'm running out of space. I'm going to quickly save this one and copy it in the next page. So that's 2 exercise. Here it is. So that one is going to be exercise number 6, correct? 6. So find how many angles? 2 more angles, right? 2 angles. I'm going to give you initial side for that one because so here's an initial side to the right side, horizontal. This is like a positive x-axis if this is an xy plane, right? So often in an xy plane, the angles are positioned like this, right? Initial side pointing to the right, like that, and so find angle measures. If this initial side is like this, what is the angle measures? Find the 2 angle measures. Once you clearly understand the angle involving initial side and terminal side, often they abuse and say the angle being just 30 degree, 40 degree, not measure of an angle 30 degree. They abuse it that much. So here, let's find the 2 more angle measures in degree that is coterminal to 30 degree. Does that make sense? I have an initial side here, which we're not going to really use. All we find is angle measures of 2 more numbers, right? Find 2 more numbers that coterminal to 30 degree. We're running out of time. Sorry to cut you off like this, but how about this one? There are no unique answers. You can add different numbers and you get a different answer. So first, easiest one is I have 30 degree. I add 360 times 1, right? And that's going to be 390, and it's not equal to 30 degree. Magnitude stays like this, 390. Or you can multiply another copies of 360, but I just use -1 to play with a smaller number. Negative 330 degree, and it's also coterminal angle. If you sketch this one with the same initial side, these 2 angles will have the same terminal side as 30 degree. Okay? How about part B? I'm just going to write it down and let you go. I have pi over 3, right? what should I add to get to next coterminal 1? I have to multiply, instead of 360, 2 pi, right? Times 1 radian, right? So radian. So sometimes they omit the radian, but always indicate degree. So pi over 3, what is the common denominator? If I put 3 in there, how does 2 pi changes to what? 6 pi, right? Got to multiply same thing to numerator and denominator. So 2 pi is the same as 6 pi over 3. Now you have the same denominator, so it's a 7 pi over 3. That's one coterminal angle. Let's subtract it. Plus 2 pi times the negative 1, that's the same as pi over 3 minus 2 pi, right? So it's pi over 3 minus, what's the numerator if I have 3 in the denominator? Same thing as 6 pi. So what's the answer? Negative 5 pi, right? Divided by 3. These are the two coterminal angles. You will have web-assigned homework. Alright, like I said in the first class, you might just focus on what procedure to do to handle this type of problem, right? First is I'd like to explain a little bit more in a mathematical way. So that's how I'm going to approach. And at the end, I'll try to summarize what is the really quickest way to handle this problem, right? So I'm doing the two folds. So if I'm explaining too much, then maybe you're going to wait for the last bit. When you summarize it, it's going to be a lot simpler. So find an angle between 0 and 2 pi. Radian is missing, but it's radian. That coterminal to the given angle. So there's a coterminal angle formula. That's the term I'm going to use. Coterminal formula, maybe. Do you remember what that is? Yesterday? Yeah. There's a 2 pi n, right? Or 360 times n. Those are, I hope you remember that. So I'm going to use this official term now. In my course, it's going to be official term. So coterminal formula. So whatever the angle they're looking for, I'm going to call that one alpha. So alpha is really the measure of an angle, right? Angle is not a number, but they're abusing the term in here. So it's all about the measure of an angle. So let's just focus on the measure of an angle. So this 17 pi divided by 4 is not equal to this alpha, right, in radian. But what should be here? Right, 360 times n, right? But since it's radian, what should we write? 2 pi times n, correct? Where, what is n? N is an integer. Yeah, that's our goal. Okay, so what is alpha? That's the question. Algebraically turn that question into that. Make sense? We have number. The only thing that we don't know is alpha and n, correct? So I'm going to do this manipulation, which will be in general true and a good idea to approach this problem generally if this is quite messy, not like pretty like this. 2 pi n equals alpha, right? And alpha is an angle between 0 and 2 pi, correct? So if I divide both sides by n and 2 pi, then it's going to reveal what n should be. So I'm going to divide both sides by 2 pi. So 1 over 2 pi is the same thing. Multiplying reciprocal is the same thing as dividing, right? That is multiplied to this guy. What's going to happen if I multiply 1 over 2 pi? Do you see that 2 pi cancels? So what leaves here? What? Just n itself, right? 2 pi cancels. Then there's alpha divided by 2 pi. This is a number that you can calculate pi, and pi cancels. And you have 16 down here, right? No, it's 8 down there. Sorry about that. 17 divided by... So here's arrow, not equal, right? So it implies, and that's the next step, 17 divided by 8, which is 4 times 2, minus n, which is an integer, is equal to this number that we still don't know. However, this number is in between, this number here is in between where and where, you think? Because alpha is smaller than 2 pi, right? and greater than 2, if your numerator is smaller than the denominator, this number must be in between 0 or 1. If you treat 2 pi, if you can replace the 2 pi with the 0 as a coterminal angle, right? They're not the same. 2 pi and 0 are not the same, but coterminal. Therefore, I can that conclusion here? Yeah, this numerator alpha we're looking for must be in between 0 and 2 pi, right? So numerators are smaller than the denominator. So anything that you divided with a bigger one, the number must be less than 1. If it's bigger, you have at least one copy of it going in there, so it's greater than 1, right? If you divide 3 by 7, then because 7 is greater, you don't have one copy at least going into 3. So it must be in between 0 and 1. So that's not simple. And so here, that number is in between 0 and 1. And that's an integer, right? That's an integer. This is something we can calculate. You can use a calculator, right? So can you do that in a calculator? This must be 2 point something, correct? So I'm going to write down 2 point. Nobody's moving. All right, so I'm going to do that for you. Yeah, 2.125. That's maybe it's going to go forever, right? But what matters is the first few digits. And you have to subtract off integer such that this number here is something in between 0 and 1, correct? So what integer should you subtract from 2.125 so that the remaining number is in between 0 and 1? What could be your good guess? N must be? What should you subtract from 2.125? 2 is an integer, right? If you subtract off that, you can see it becomes a 0.125, correct? So 0.125 is in between 0 and 1, right? So n equals 2 works. One furthermore thing you have to understand is that n equals 2 is the only number that does it. If you go beyond 2, then it's going to be 3, right? If you put 3 in there, you can see it becomes negative something, 1 point, so it's not in between 0 and 1. If you go below 2, if you plug in 1, you can see it's 1.125. It's not in between 0 and 1. So you can easily see by how it increases and decreases that n equals 2 is the only answer. Correct? Now once you know n equals 2, then your alpha going back here, alpha is n equals 2 there, right? So it's a 17 pi minus 4, divided by 4 minus 2 pi times what's n? 2. So if you simplify this one, and that's going to be the answer. Right? So let's do that. 17 pi divided by 4, that's 4 pi there, right? But if you have a common denominator, what happens to that is a 16 pi, is that right? That's a 4 pi. But if you multiply 4, it becomes a 16 pi. Does that make sense? Yeah. So 17 pi minus 16 pi, that's a pi, right? Divided by 4. So this angle, 17 pi divided by 4, is coterminal to pi over 4. And that pi over 4 is in between 0 and 2 pi. That would be systematic and algebraic way of solving this problem with everything justified very closely. So, if it's repeated like this, everything is the same, then what's the summary? All you need to do to get this number 2, or whatever n equals 2, to do that, is that you divide 17 pi by 2 pi, so it's the same as this one, and write this one in the calculator. An integer part, which was this 2 right there, right? That's how we chose a 2 in there. And plus fractional part. That's easy. If you look at number 2.125, 2 is integer part. Whatever follows after 125 is a fractional part, right? So from there, you can easily conclude my n is that integer part, right? if you look at this bit here, we skipped all that and just directly calculate. This is the minimum thing you need to do to get the answer of this exact same problem. Okay? So once you have that n, what do? Well, alpha is 17 pi divided by 4 minus 2 pi times n in there. Okay? All this thing works if that given angle, 17 pi divided by 4, is a positive angle. If it is a negative angle, I think you have to go one more. So if n equals that integer, if the given angle, I'm going to call that one beta, if beta is positive, and our choice of n will be one more. That integer part that we saw over there, part plus 1, if beta is less than 0. Because if this were negative 2.5, think about that situation, negative 2.125, then what should I subtract in here, that number, such that this whole thing becomes greater than 0 and less than 1? If you just choose that negative 2, so we have negative 2 there, you can see that negative 2 disappears, leaving only negative 0.125. But that's not in between 0 and 1. It is a negative 1 and 0. So you have to go one more step in there, which I think is adding one more there. Then is negative 1, the positive 1, and if you subtract that, I think that should be correct. Because I'm throwing in one more. I hope I'm not. So let me go ahead and make sure that this plus 1 part is correct. Negative 125, what should I subtract in here? Is negative 1 the answer? So that's negative 2.125 minus positive 1. If you add that 1, it doesn't work. So I think it should be negative 1. I hope that's correct. So negative 1, it means negative 3. Negative 3, then it's a positive 3. Now, if you do positive 3, what is it? Then it finally becomes number 0.875. All right. So although what you see in the integer part in here, it's negative 2. Negative 2 is not the answer, and you have to subtract one more. But usually, once you get the negative number, you can add one more, things like that. So that's the general algorithm. If you have angle beta, and you want to know what is the coterminal angle in between 0 and 2 pi, you divide that number by 2 pi, and you write the integer part. You write it like this, the integer part and the fractional part. And your choice of n is just that integer part if this is a positive number. And if it is not a positive number, and you have to go backward one more and subtract that number from like this, and then you will end up at getting the positive number there. All right? So here's your exercise. Number 1 today. What if my beta is 100 and find coterminal angle alpha in between 0 and 2 pi? Does that make sense? So I want you to think about the shortcut, not the first thing that I did, which was justification and explanation. So let's do this a little bit of outline. What was the first thing we need to do? What is that we calculate? Beta is divided by what number? 2 pi. Does that make sense? It tells you how many rotation is involved in there, right? Beta is divided by 2 pi. That tells you, oh, how many rotations involved in there. Second part is carefully determining what that n part is, right? And thirdly, we calculate alpha. That's the outline. And one of the things is that 100 does not have pi in it, right? So you shouldn't throw in pi in there. 100 is the magnitude of the radian angle. All this thing I want you to calculate to 4 decimal places. Once you calculate this one, and I want you to deal with it so alpha is in radian to 4 decimal places. That's what I want. So if you have written down the problems correctly, and I want you to work on this problem on your own, and I'll be doing the problem here. When you're using a calculator in the denominator, make sure you put parentheses around the denominator, right? So that it recognizes up to which thing you type is a denominator. Right. Was that okay? That makes sense? So first you divide it, and it tells you there are 15 2 pi rotation is involved and a little bit more. So 15 is the number of revolution you have to subtract off. So n is 15. So if you subtract from that large magnitude angle and 2 pi of 15 rotation in there, then it leaves 5.75. This is in between 0 and 2 pi, which is roughly 6.2. And this is the only angle in between 0 and 2 pi, which is coterminal to angle 100 radian. Any question? All right? So if you got this one right, give yourself 2 points at the top of that sheet. If you half of them right, 1 point. Did not get right, 0. If you don't want to grade this whole thing, then you don't have to grade it. But if you're grading, I want you to grade everything you do. All right, exercise number 2. How about when beta is 1 and negative 150? And then I'm going to copy that thing there. Find the coterminal angle, alpha, that is in between 0 and 2 pi to 4 decimal places. And beta here is negative 150. All right, how was it? Was it okay? If you accidentally tried negative 23, you end up at a number that is negative, but fairly small. Then you can, oh, what can I do? You can't just change the sign and determine this number. You have to add one more 2 pi, right? One more 2 pi, that's still coterminal, and then you know it's going to change that to positive angle, but still less than 2 pi. So that's the right fix, but it's already in here. If you just bump up the magnitude like that, and then it's going to take care of it. It's equivalent to adding one more 2 pi at the end. Make sense? That's why we're doing that. Yes?
You can, to like show it logically though, you can just go ahead and add.
All right. Any question?